If this is a meniscus, how do is the where will be this? So I'll say liquid here, and this air. Tell me where pressure will be more, and let R be the radius of the meniscus. Fine. So this will be the R. So then what you're going to write? You're going to write equation as P1 equal to P2 plus 2T by R. Yes, yes, this effect. This is the meniscus we'll call. This is. Similarly, it can happen like this also, where this will be liquid and this will be air. Now also the meniscus, let it be equal to R. Now in this case, what you are going to say? Now also the situation is same. P1 equal to, so here P2 is what? Equal to P naught, because this air, no? So finally this equation will become 2 St by R. Similarly, now this air, what is the pressure at 1? Pressure at 1 will be P naught. So what is the equation? P1 equal to P2 plus 2 St by R. Then what is the pressure at 1? Will be P naught. So what is P2 equal to now? In this case, P2 will be P naught minus 2 St by R. Able to understand? So we are not talking about some in the liquid or outside the liquid. There's everything. Right. So there's everything will be liquid. Pressure inside the liquid must be more than that other side of the liquid. Need not know. It's like a, shall we say that the pressure will be more on concave side than on convex, not inside the liquid, outside the liquid. I agree with this condition. Okay, now there's a background is what we needed. Huh? So rest of everything we can manage very easily. Okay, let me take a capillary. Tube is needed. This is the capillary tube. We'll take it. The same capillary tube. I'm showing two instances. So it is immersed in a this will be our container. Okay, there's everything is a liquid. So here this will be the liquid. Huh? So I took a capillary tube. All of you, what do you mean by capillary tube? What can be radius of capillary tube? Usually this will be radius will be of order millimeter. Huh? If radius is 1 centimeter, 2 centimeter, we don't call capillary. Of course, you can call a pipe, but capillary, what happens? Strictly, the radius should be of order millimeter. Example, the refill in pen, the refill will be there. No, there is an example of capillary tube, and it will be long. How much? 1 meter long. Capillary tube. It will be 1 meter long. If you want, you can purchase it. They're available in some laboratory selling equipments. Now, a glass capillary tube, I brought it. So when I lower end of the capillary tube comes in contact, so the level of water, because the water will wet glass. So what we expect the meniscus to be like this, no? Agreed, all of you? We expect meniscus to be like this. Okay, let's get into the pressures here. So this is the free surface. So pressure here. Uh, for first, let me take here. No? So pressure here 1, 2, 3. We are very sure. What about here? Everything air, no? And what is this? This is the free surface. What should be the pressure at 1 and 3? Pressure at 1 and 3. What should be the pressure at 1 and 3? Pressure at 1 and 3 should be equal to P naught. Okay, we'll agree this. And definitely pressure at 1 should be, pressure at 2 should be less than 1. Come for this. Am I right? On concave side will be more than convex side. No? So pressure at 2, what do you expect? Should be less than 1. So here, what do we get? P2 will be less than P1. You try to see and according to fluid statics. What about 2 and 3? They're on horizontal line. 2 and 3 are on same horizontal line. So what should be the according to fluid statics? If you draw an horizontal line inside a liquid, what should be the pressure at 2 and 3 should be equal according to fluid statics. Pressure at 3 equal to 2 as they lie on same horizontal line. Tell me, okay, what is correct? So here, according to the situation, what I'm saying, P3 equal to P naught and P2 less than this one. So shall we conclude like this? Therefore, P2 less than P3. P1 equal to P3 equal to P naught. P2 less than P1. So therefore, P2 will be less than P3. This is according to the surface tension. There's a one idea. Next, according to the fluid statics, this idea. I'm drawing it nearby so that a student has to put effort here. I would have written somewhere. It's of no use. This idea too. Tell me like who is correct? Both are contradicting each other, no? I may use word. Shall I use word? Contradicting. All of you. If you come for fluid statics, okay, fine. 2 and 3 should lie on same horizontal line, so pressure should be equal. But you look at the surface tension here, because the water will wet the glass, because there's a water. And what is this? This is glass. So what do you expect now? P2 less than P3 you're telling, and according to fluid statics, you are saying that P2 is equal to P3. Which one is correct? Both are contradicting each other, no? So idea 1, idea 2 are contradicting each other. Tell me like, so there should be some solution for this. Is it both the pressure on the concave side should be more than convex? Is it a proven thing? Yes, it's a proven thing. If a liquid at rest, then if you draw an horizontal line, pressure at all points on horizontal must be equal. So that is also a proven thing. But both these things are contradicting each other. So therefore, there is some problem is there. What is the thing? The liquid, what we assume, will not be there only. In fact, it is going to rise up here. So why it will rise up? So that pressure at 2 will become more than will become equal to P3. So but practically what I see is that pressure at 3 will be greater than P2, or P2 will be in fact less than P3. In fact, this is correct. Here what happened? This not happens. So to make this happen, what happened? The liquid has to rise here. So therefore, now what is the next situation? So the liquid what happened will rise to and height. It's a very important to analyze first, then we'll go for equation. So now what happened to make even the fluid statics idea to make it valid, no? So in fact, the liquid what happened will rise like this. It will rise to an height. Let's get into our thing. So this was a 2. 1 and 2 are same now. It doesn't matter. So now this is 4. This is 5. Let R be the capital R. Small r be the radius of the capillary tube. Capital R will be the radius of the meniscus. Now, so this should be the angle of contact. Can you remember this? We used to how you define angle of contact. Now this is the angle of contact. If this is the angle of contact, 90 minus theta, this will be theta. This will be theta. Okay, this here it is here. Able to see the diagram. This is very important. Okay, let's get into all the things one by one. So what is H? H is measured from here. H is measured from here. Now what will happen? Pressure at 3 equal to 2 because this is a wrong. It will be wrong. Something wrong. This is what correct. Okay, now let's come for one by one. Let's write all the things. What is the pressure at 5? What is capital R? Small r is radius of capillary tube. Just as a small idea, once you clear all are based on all the numericals what I discuss are based on this one only. Capital R is radius of meniscus. What do you mean by meniscus? This particular thing is called as a meniscus here. The curved surface, the curved free surface is called as a meniscus. Meniscus means one which is like a some saucer, all of you, some or what do you call that one? Kadai, bowl. The shape of free surface will be curved here. That is called as a meniscus. And theta is an angle of contact. Water, this will be the density rho. Okay, let's write here. Pressure at 5 should be equal to P4 or first we'll equate atmospheric pressures. What is the pressure at 3 and 5? Because there's a free surface. Pressure at 5 and pressure at 3 should be equal to P naught and 3 and 2 are on same horizontal line. So it should be equal, no? So pressure at 5 at 3 is equal to 2 is equal to P naught. One is of no discussion. One I'm not interested because 1 and 2 they'll be on same horizontal line almost. Okay, no, this is the thing. So pressure at 5 should be equal to P4 plus 2St by R. Pressure at 5 equal to P4 plus 2St by R. Then pressure at 5 is how much? P naught. This is the discussion earlier we made. No, let's write manometric equation from 4 to 2. Now, if you want, I'll take it out that one. You'll get confused. Okay, that horizontal line also, I'll they lie on same horizontal line. No? That's why the pressure at this one. Okay, let's write manometric equation. P4 plus rho GH minus P2 equal to 0. So what is P4? P naught minus 2 St by R rho GH. P2 is P naught. So therefore, what is H is equal to 2st by rho g r. Let's write some, look at that triangle. Cos theta, what you can write, small r by capital R. So further, this H, what we can write it as 2st by capital R, you can write it as rho g by small r by cos theta. Theta is what? Angle of contact. So this is the expression for the height to which the water will rise in capillary tube. Able to understand? So that the conditions here, this is our expected answer. Everywhere this one. Okay, now what is the shape of meniscus? Next question comes. The shape of meniscus will be hemispherical. Here now. Hemispherical in shape. Okay, agree this. Any doubts? Because this is a basic one. Huh? What are these? This dotted line? Force by the capillary glass capillary tube on the meniscus it is. And this should be the angle of contact, no? Angle drawn between tangent drawn inside the liquid and the solid. There's a solid, there's a liquid, no? And the tangent is drawn and we measure this angle inside. So this should be the angle of contact. If you want, you can write theta here also. So this should be the nothing but force exerted by the capillary tube on the meniscus, that one. Any doubts? If you have, you can clarify. So I'll because all numericals revolve around this one. Okay, we can also think this in another way. The same thing. So it's the same discussion. We'll take it in another way. Suppose say the capillary tube. Little bit some bigger diagram. Let me take it. It is immersed in a. In books, they don't show container. It's not needed. Just will immerse. No. So again, don't take it in other way. That one, sir. Books not given. There's a free surface. There's another method is what I'm using here. No, so this is what I just used the pressure concept. Let's talk in terms of force due to surface tension. We'll see. Who will balance the weight of the liquid column? What is the weight? I think inside the capillary tube, there's amount of some liquid is there, no? Because water will be denser one. So who will balance that weight of the liquid? And definitely I can say force due to surface tension. Okay, no. Let's get into the discussion here, no? This is the force due to surface tension. Or in the books or pen, we just show this as surface tension. Surface tension is a vector, no? In fact, we can show like this also. And this is what the radius of curvature. This is R, this is R, this is R, this is smaller, this is theta. Agree this. So now it's a hemispherical, no? So go for this one. So this is that H density rho. So shall I say the weight of the liquid will act here? Who will balance this weight of the liquid column? That's what my question. Definitely the force due to suffocation. If you look at the meniscus, how the meniscus will be. Is that okay? The meniscus should be of this particular shape. Please do follow basics. You do have very beautiful questions in this topic. Only the student will not minutely observe things. The meniscus is, or how the meniscus, anybody? Hemispherical? Not a, it should be hemispherical, no? So, and what is the radius? The radius will be, you can take R. So how the force due to suffocation? Here it will act like this. Will act only at 2 points or several? It will act at all these points. I think a radius, let it be. So tell me, like, who will balance this and what is theta? There should be the theta, no? Agree this? This will be. So now that theta, it has to be brought it here. You have to bring it here. No, who will balance force due to suffocation? The weight of the liquid has to be balanced, that one. So I'll write it now. Force due to suffocation should balance weight of the liquid. What is the force due to suffocation? This will be the radius of the tube, no? For your, I think already I written there. I'll show it again, this one. Okay, agree this. This will be. So what is the radius of this ring? Should be 2 pi r perimeter. So anybody, can you tell me, like, what I should write? 2 pi capital R or 2 pi small r? 2 pi smaller that I should add. So suffocation into 2 pi r. So that force and vertical component of it, cos theta, should balance the weight of the liquid. What is the weight of liquid? Rho pi r square. Because what is radius? Rho pi r square h into g. Pi r square h will become volume. So if I solve this, so what is the equation I'm getting? 2st cos theta by rho g. I think the same equation what I brought it. No. So here what I'm taking, the force due to suffocation will balance the weight of the liquid column. And now your task question, sir. What you took? Okay, but here we didn't, we have neglected this. It's the volume of the liquid in the meniscus is neglected. So basically, how it will be? It will be of like this, no? This is negligible, we are saying. If you consider that in books, they are given how to calculate weight of this, I think in the 2 pi r square into that particular distance, you can work out. It's there in book. Just if you want, you can see once the formula. Even if you consider the weight of the liquid column, it will be very small amount of liquid. So that usually will neglect it. Okay, there's a expression for the either way. That one means like the force due to surface tension in fact will balance, because see, I think this is very important in applications. We do solve problems using this approach only than this one. They're using the pressures ideas, but in applications all know what all we get questions are based on this one. So what is the equation I should write? The weight of the liquid column is balanced by force due to surface tension acting at meniscus. Where that surface tension will act inside the liquid or only on the free surface? Only on the free surface, no? So what is the free surface? This is our free surface. I think I should show some thick line. This concept is very important. Okay, this is the free surface. So what is the basic overall theme of this? The force due to surface tension the force due to surface tension at meniscus is equal to weight of liquid column in capillary tube. Finish. This idea from here we have proceeded here. Okay, now I'll go for all other the conditions. I think anybody can remember this formula. Now you have to just remember all this basic formula here. Okay, let's get into one by one. First here, the hemispherical cup. What it is? It's a they may ask you simplest questions like this: how the meniscus will be in capillary tube? Hemispherical cup it is. Okay, let's bring some small changes here. Now I'll go for some application type of problem. Okay, this is the let me draw all the pipes first. Let me draw first horizontal line one. Free surface of liquid it is. I'm giving good diagrams because they are very important. Students often they get confused. If the meniscus were like this, books only we have they have shared ideas without diagram, huh? So very difficult for students to assume that one. So I'm helping with a diagram. So in many numericals, these ideas are going to help us a lot. Please just do analyze. Okay, there's a water later on, I'll share it. Correct. Okay, I think, yeah, it's almost completed. Okay, let's, you make observation of meniscus here. And the capillary tube, the radii also I'm changing. So here, look at the angle of contact, theta 1, theta 2. So this is the level what we take it, H1. So now if I change angle of contact is not a fixed parameter. That's what I am trying to bring it here. We thought like angle of contact is something, but angle of contact is, you can change it, but you take water, you add some detergent, the angle of contact will change. There's a core idea of the what we use for detergents, shampoos, soaps, everything. No, so we are for, if when you apply the detergent, what happens? The angle of contact will change. That variation of angle of contact will help us to clean our bodies or the clothes. That's the concept. Okay, now anything, radius of capillary tube has not changed. The radius of capillary tube is as it is. We are not disturb the radius of capillary tube here. Angle of contact. So then, what is the formula? We have, where is our formula? H equal to cos theta rho gr. I'll write the formula here. Okay, let's assume that somehow the angle of contact is varied here. Then radius of capillary tube is didn't change. Only the shape of meniscus has changed. Able to notice the shape of meniscus has changed. And this H1, H2 will measure, we do measure like this here. Okay, are able to see things clearly, no? H1, H2. So according to this formula, surface tension is same density of liquid, same surface tension. So then if theta changes, then H has to change. So therefore, what is the equation I can write now? H1 cos theta, H1 by cos theta 1 equal to H2 by cos theta 2. No, if theta 2 greater than theta 1, as cos value increases. So what do you expect now? The ratio of that should be constant here. So H2 equal to, H1 is certain value initially. So as theta 2 greater than theta 1, 60 degrees, and let this be equal to say 30 degrees. So H2 should be less than H1. Shall we go for this? H2 should be less than H1. That's what I think in the diagram may not appear. Okay, we'll do one thing. I'll do adjustment. H1 by cos theta 1 equal to H2. So theta 2, I'm showing it more than theta 1. So cos theta 2 will be theta 2. Diagram H2 more than H1 is appearing. Yeah. Okay, let it be no problem. Huh? There's a formula I'm trying to bring. Okay, now let's come for this one. So there's a next is the capillary tube. So this is R1. If I increase the radius, what will happen to the? Okay, some corrections I do. No, next thing. So what shall we do now? Look at the radius R1, R2. So if this is H1, this will be H2, no? Now what should be the equation? H1 R1 should be equal to H2 R2. And look at H2, no? H1 R1 by R2. What do we expect H2? H2 should be as R2 greater than R1. So H2 should be less than H1. So if you increase the radius of the capillary tube, what will happen to level of liquid inside that will fall. Level of liquid inside that will fall here. So this will be the basic condition. Even you can adjust even for radius of meniscus also. H1 R1 equal to H2 R2. Here this you can bring it here also. H1 R1 equal to H2 R2. So all things are possible. Hn cos theta, you can compare. Provided angle of contact here, it will wet completely. The water will wet completely that one. That's what I took it, this one. Angle of contact, both the cases 0. I'm unable to show that clearly, that one here. So it will wet completely. So this water wets capillary completely. So there's a basic condition. Fine. So you do have some questions. So I'm trying to give diagram, but this is what happens here. Even you can write H1 R1 equal to H2 R2 also. Provided angle of contact remains. There's no need of angle of contact if you're going for that one. So even we can have H1 R1 equal to H2 R2 condition also. Agree this? So these are the different cases will come. I'll show that H1 R1 equal to H2. Okay, not needed. Okay, there's a first case. You do have questions in the books. Huh? So there's a first case. There's a second case. Even third case, H1 R1 equal to H2 R2. You don't draw diagram anything. Directly take help of formula and analyze it. Okay, so now we'll take some different application-based problems.